This video is about topic 4.9, oxidation reduction or redox reactions. The objective for this topic is to represent a balanced redox reaction equation using half reactions. So in a redox reaction, one reactant is oxidized and one is reduced, hence redox or oxidation reduction. The extent to which oxidation and reduction happen must balance. So remember, when a redox reaction occurs, we're looking at transferring or moving of electrons. And the amount of electrons you remove from your substance that is being oxidized needs to be the same amount that is gained by your substance that is being reduced. So that's what we mean by the extent must balance. So we have to think about our total number of electrons changing being the same. The oxidizing agent, so the thing that causes the oxidation, is ultimately reduced. And then the opposite also applies. The reducing agent, so the thing that causes the reduction to happen, is oxidized. So they go hand in hand. We oftentimes use half reactions to balance redox reactions. So if we look at our example of solid copper with silver ion, forming copper plus 2 ion and solid silver. So anything that's in its solid elemental form has an oxidation number of 0. So our copper is starting at 0 and it's ending as a plus 2 charge. So it has the charge of the oxidation number of whatever the ion charge is. So going from 0 to plus 2 means that it's losing electrons, because remember, electrons have a negative charge. So if you get more positive, you're losing electrons. Anything that loses electrons is oxidized. Our silver is going from silver plus 1, so an oxidation number of positive 1, to silver solid, elemental silver, so it has an oxidation number of 0. So going from positive 1 to 0 is becoming less positive or more negative, and therefore is gaining electrons, and we call that reduction. Now, if you notice, our overall reaction has 2 silver ions and 2 silvers. So we're going to look at how we got that by balancing half reactions. So half reactions separate out the oxidation and the reduction pieces. So when we separate out these changes, we show electrons being either added on the reactant side if it's being gained. So if it's going through reduction, and if it's going through oxidation or losing electrons, we show the electrons on the product side. Now, if we look at our two half reactions for our overall reaction, in order to balance our total number of electrons, we need to multiply the top half reaction by 2, because silver is gaining an electron and copper is losing 2 electrons. So we said earlier that we need the extent to balance. So we need to be transferring the same total number of electrons. So if copper is going to lose 2 electrons, each silver can only gain 1, therefore we need twice as much silver to gain those 2 electrons from copper. So by balancing the two half reactions and making sure that our total number of electrons before and after is the same, we can end up with a balanced overall redox reaction. And so then when you add these two half reactions essentially together, our electrons cancel because they're on both sides of our reaction arrow, and we end up with 1 copper plus 2 silver ions, forming a copper plus 2 ion and 2 silver solids. So that's how we look at the half reactions for oxidation and reduction.